Hello everyone. We are looking at phase 5, chapter determinant exercise 1, and we have here question number 47. So let's look at the question. As we can see, the question, okay, there is a little bit of, so there is a matrix A is given to us, and we have to verify this relation for the given matrix, okay? And this is the identity matrix. We know for a 2 by 2 identity matrix is 1, 0, 0, 1, and O is the null matrix. And we have to use this to find A inverse. We have to use this to find A inverse. Yes, in the solution, it has been corrected. So the starting point for this is for just finding A inverse, I think you don't have to go through all that. We can easily find. But this relationship is important because this can be then applied for 3 by 3 and so on. So we will start with the characteristic equation A minus xi. Determinant of A minus xi is equal to 0. And this is a unique relation for the given matrix. So we will just go ahead. So 3 minus x, 2 and 1 minus x, find the determinant value of this equated to 0. So if we do that, 3 minus x into 1 minus x minus 4 is equal to 0. If we solve it, so we will find the relation. So x square minus 4x minus 1 is equal to 0. Now, this we know is the characteristic equation of this matrix, and from the Cayley-Hamilton theorem, we know that every matrix satisfies its own characteristic equation. Satisfies it, its own characteristic equation. So, if this is the characteristic equation of this matrix as we found, then a squared minus 4a minus, since it's a matrix equation, we can replace 1 by identity is equal to 0. So, this is the matrix relation now, which is what we had to prove. And how do we use it to find the inverse? That's simple. What do we do is we multiply both sides of the equation with inverse. So A inverse into A. So A square will split at A square. A into A minus 4 into A inverse into A minus I, okay, minus A inverse into I is equal to 0 remains 0, whatever you multiply this. Now, this is nothing but I, and I into A is A minus this again is I. So, this is 4. This is 4I minus, and this is inverse. So, A inverse is equal to 0. We take it to this side. So, A inverse is nothing but A minus 4I. A minus 4I, we just do a simple subtraction, multiply 4i from A, subtract 4i from A, and we get the inverse. So this is another way of finding using the characteristic equation, finding inverse. For a 2 by 2, you may not appreciate it so much, but you will understand it's very, very useful for a higher order method. But this is just one example where we can just take it forward, the concept. Okay, thank you.